Hello and welcome to this presentation about my Python-based examination seating arrangement system. In this video, I'll be discussing the technologies and libraries I use to develop this application, walk you through its working, and then talk about its future scope. Python language. So first off, let's talk about the foundation of this project, Python, by Pandas. Python is known for its simplicity and versatility, and that's exactly why I chose it for this project. It handles a wide range of tasks with ease, and it's been especially helpful in working with data and creating the interface for the application. One of the best things about Python is that you don't have to worry about specifying data types when declaring variables, which speeds up the coding process. Functions make it easy to reuse code, and with loops and conditionals, managing different parts of the seating arrangement was straightforward. Deep dive into Pandas. Let's start with one of the core libraries that I used extensively in this project, Pandas. Pandas is an incredibly powerful tool for data manipulation and analysis, and it was perfect for this project because I needed to handle large datasets for both the students and the classrooms. The primary data structure in Pandas is the data frame, which is like a table where rows represent records, in this case, students or classroom data, and columns represent attributes like enrollment number, branch, year, etc. Here's how I used Pandas in my project. Data loading. One of the first tasks in the application is loading classroom and student data from Excel files. With Pandas read_Excel function, this was straightforward. Pandas allows for easy data reading from various formats. But in this project, I specifically focused on Excel because it's a format most administrators are familiar with. Data frame operations. After loading the data, I needed to perform various operations on it, like grouping students by branch and year. With Pandas, this was easy to accomplish using the groupie function. This allowed me to ensure that students from the same branch and year were identified and handled accordingly by the seating algorithm. Data cleansing. Another important task was to clean the data. Real-world data is often messy, with missing or incomplete records. Pandas offers several methods for detecting and filling missing values. For example, I used dropNA to eliminate incomplete records and filler to fill in any gaps with default values. Data export. After generating the seating arrangement, I used Pandas again to export the data back into an Excel format. This feature allows users to save the final seating plan and share it with others. The to_Excel function made this process smooth and efficient, and I paired it with XlsxWriter to ensure the output was well formatted. Tkinter for the user interface. For the user interface, I use Tkinter, which is Python's built-in library for creating desktop applications. It's a simple but effective way to build GUIs, and it worked perfectly for this project. With Tkinter, I was able to create an interface where users can manually add or delete classrooms, load student data, and view the seating arrangements. The GUI is set up using buttons, labels, and grids, and it's designed to be very intuitive. For example, you can load an Excel file, generate the seating arrangement with one click, and then view the seating layout for each classroom. It also allows users to click on any seat to get details about the student assigned to it. File handling with Tkinter. File handling was another important aspect of the project. I used Tkinter's file dialog to allow users to easily load and save Excel files. The Pandas library, in combination with XlsxWriter, made it really easy to read the classroom and student data and export the final seating plan back into Excel format. This way, users can save and share the seating arrangement for future reference. Working of the application. Let me now take you through the overall working of the application. Let's go through the working of the application step by step. Adding or loading classrooms. The first step in the process is setting up the classrooms. Users can either manually input the number of rows and columns for each classroom or load an Excel file containing classroom data. Each classroom has its own layout, and this data is stored in the program to be used when generating the seating arrangement. Loading students. Once the classrooms are set, the next step is loading the student data. Users can load an Excel file containing details about each student, including their enrollment number, name, branch, and year. The student data is essential for ensuring that no two students from the same branch and year are seated next to each other. Generating the seating arrangement. After the data is loaded, the application generates the seating arrangement. This was one of the more complex parts of the project because the algorithm needs to shuffle the students and place them in a way that prevents conflicts. The program checks each seat and its surrounding seats to ensure that students from the same branch and year are not seated next to each other. Viewing the seating plan. Once the seating arrangement is generated, users can view the plan classroom by classroom by classroom. The seating layout is displayed in a grid, where each seat corresponds to a student. Clicking on a seat will display the student's details like their name, branch, and year. Exporting the seating plan. Finally, the seating plan can be exported to an Excel file, allowing users to save the results for future reference. This feature is especially useful for administrators who need to share the seating arrangement with other staff members or print it for use on exam day. Future scope. Looking ahead, there's a lot of room for future development. Enhanced customization. I could add more options for customizing the seating rules, like taking into account exam subjects or specific seating preferences for students. Web-based version. Another idea would be to turn this desktop application into a web-based app. With frameworks like Flask or Django, this seating arrangement system could be accessed from anywhere, making it even more useful for larger institutions. Integration with other systems. The system could be integrated with existing student management systems to automatically pull data, further automating the process and reducing the need for manual input. Data analytics and reporting. Finally, adding a data analytics feature to analyze seating patterns or even keep track of seating history over multiple exams could provide valuable insights for schools and universities. Conclusion. In summary, this project shows how Python and its libraries can be used to solve real-world problems in a simple yet effective way. By using Pandas for data handling and Tkinter for the interface, I was able to build a tool that makes the seating arrangement process much easier and more efficient. There's definitely potential for this project to grow, especially in terms of scalability and automation. So, thanks so much for watching. I hope this gave you a good overview of the application and its possibilities. If you have any questions or feedback, feel free to reach out.